guys, let's get back to the concept of elasticity. So in the previous video, we looked at an example of you running a bakery and your costs are rising. So as a result of that, you are going to increase the price of cakes you're going to be selling. And then what we answered was how many more or less cakes we sell is what elasticity tells us, right? So we've gone over the definition, we've gone over how to calculate numerically. Now we're going to talk a little bit more about graphical representation of price elasticity of demand. So just to make sure you haven't forgotten, so the formula is the price elasticity of demand is the percent change in QD divided by the percent change in price, right? So if you open it up, it's the change in quantity divided by the original quantity, which is Q0. Q0 just means it's the original quantity divided by change in price over the original price, and then you're multiplying the denominator and numerator by 100. So as you get more used to the formula and you practice it, you know you can just drop both of the hundreds because they just end up canceling out. So a convenient way to write this formula is, if I just cancel this out, is change in Q over Q0 times, I'm just taking the reciprocal of this, P0 over change in P. All right, so, or one more step and we are done with this. It's change in Q, change in Q over change in P times P over Q. So if you just look at that formula, P0, Q0, it's change in Q over change in P times P over Q. So now we'll talk about how do we graphically represent this. So we looked at, let me go back so you're not concentrating on that slide. We looked at inelastic demand curve, elastic demand curve, and then perfectly elastic, perfectly inelastic, and unit elastic. So those are the 5 scenarios we've looked at. Now we're going to graphically represent that. All right, so make sure if you don't understand the definitions of those, again, the previous video is where you will find that. So a perfectly inelastic demand curve is where if the price changes, you do not adjust your behavior at all. So the demand curve will be vertical, because here, if the price falls by 10% or rises, you're not adjusting your quantity at all. So graphically, you will continue buying Q1 units of whatever this good is if the price changes. So it's very hard to think of examples of demand curves which is perfectly inelastic, right? So maybe visiting a surgeon might be one, right? Because if you break your hand or you break your ankle or you break anything else, you have to get surgery. You're not going to live your life with a broken ankle. So if the doctor charges you more amount or less amount, you're not going to get more surgeries, right? So if the doctor charges a lower price, you're not going to say, well, let me get surgery on both ankles, obviously. Neither are you going to say that if the price goes up, I'm going to wait. So that might be an example where the demand curve for surgeries is perfectly inelastic. All right, and again, it means the numerical number is going to be 0. Next thing is inelastic demand curve, which is if the price changes by a specific percent, you do not adjust your behavior a whole lot. You adjust it more than the previous one, but not a whole lot. So the price goes down by 10%, quantity rises by less than 10%. All right, so the numerical number for this elasticity is more than -1, and you also should remember that it's less than 0. So it's going to be a fraction. It's going to be -0.5, -0.1, but it's not going to be less than -1. And then graphically, you know that if the price changes, your Q does not adjust a lot. All right, so that's inelastic demand curve. Unit elastic is if the percent change in price and quantity is the same. So your number is going to be -1. All that means is if the price goes up by 1%, you'll buy 1% less of the quantity, and if the price goes down by 1%, you'll buy 1% more of that quantity. Right, so that's fairly simple. And then the elastic demand curve is that if the price goes down by 10%, you will adjust your behavior a lot. And right after I'm done with the slide, I will try and put most of them together just so you can compare. So this number is going to be less than -1. So the numerical part you should remember from the previous video, right? So that I'm not spending too much time on that here. So now, if this number is -5, then the demand curve is very elastic. But if the number is between -1 and 0, then it's inelastic. So the last one is perfectly elastic, which is that if the price changes, you adjust your behavior by an infinite amount. Again, this is the least realistic of the demand curves, but mathematically, it is a scenario, so we have to cover it. And then if your demand curve is perfectly elastic, it's going to be horizontal. So let me graph 2 of the common scenarios. So you have quantity, price. Let me draw 2 graphs, and then we will see how you differentiate whether a particular demand curve is elastic versus inelastic. So if you increase price by this much, and then you keep it same across the 2 graphs. Now the question is, you know that the law of demand tells you that we are going to buy less. So the question is, how much less are we going to buy when the price is going up? So let me draw two different demand curves. One I'm going to draw like this, and another one I'm going to draw like that. So I would never suggest you memorize these things. If you forget, is the elastic demand curve more steep, or is the inelastic demand curve more steep, just draw it out. Draw out both of them, see what happens when the price changes by the same amount, and your answer will be given to you. All right, so if the price goes from P0 to P1, we see that the quantity we buy goes down, but by this much. But on that graph, if the price goes up, then now the quantity that we buy goes down by that much. So you don't have to memorize it. The only thing you should remember is elastic means there's a lot of room. So this is an elastic demand curve. And inelastic means there isn't a lot of room. So this is your inelastic demand curve. So that's an easy way to remember it, is you draw two graphs, and if the demand curve is very flat, it's relatively elastic. If it's steep, it's inelastic. If you take this to the extreme case, it becomes perfectly inelastic. And if you take that to the extreme case, it becomes perfectly elastic. So those are the graphical representation of what it means to say that the demand curve is elastic or inelastic. In the previous video, we talked about what the meaning is, what the difference is. And it might seem technical and boring, but it's very important. Right? If you go back to the original scenario and you said if you're running a business and you want to raise prices, you know less people will buy a good. So if you raise prices and only few people don't buy a good, then you're happy. But if you raise prices and the number of people who don't buy a good is a very large number, then you're not happy. So this has a very realistic implication for in our daily lives, even though technically speaking it gets a little not interesting. But make sure you understand it, the concept of elasticity, both theoretical and numerical, and now graphical. And the next time we'll analyze it a little bit more, what happens to your revenue. Right? So what happens to your revenue, that'll be one of the things we talked about when you have an elastic or inelastic demand curve. So review these concepts, review the graphical and theoretical representation and numerical representation of elasticity before you come watch the next video.